Hello everyone, today we are going to be learning Heat Part 2. This is Concise Physics by Selena. So let's get started. This is of three types: Celsius scale, Fahrenheit scale, and the Kelvin scale. It's scales of temperature of three types. Celsius scale named after scientist Celsius, and it is 0 degree to 100 degree. Fahrenheit scale named after Fahrenheit, and it's 32 degree Fahrenheit to 212 degree Fahrenheit. And the Kelvin scale is 273. It is named after Kelvin, and ice point is 273 Kelvin and 373 Kelvin. So these are the three scales of temperature. Now the relationship are ice point of the Celsius scale, which is 0 degree, and the ice point of the Kelvin scale is 273. So that is the relation. The steam point is 100 degree and 373 Kelvin. So that is what. So as I was saying, now we are going to be learning about the Celsius and the Fahrenheit scales, the relationship. Ice point 0 degree and 32 degree Fahrenheit is. The steam point is 100 degree and 212 degree Fahrenheit. So 100 divisions of Celsius scale is 180 divisions of Fahrenheit scale. So thus there's 180 upon 100 divisions of Fahrenheit scale and 9 upon 5 divisions on Fahrenheit scale as well. We can also say that. Okay, so now next we are going to be learning effects. The effects of heat. Heat produces mainly the following three effects. What are the three effects? Change in temperature of the body, change in the size or shape in the body, and the change in state of the body. Change in temperature of the body is when the body is heated, its temperature rises, and when it's cooled, its temperature falls. It depends on the material of the body, the mass of the body, and also the quantity of heat which is given. Now the change in size, and when a body is heated, thermal expansion happens. Thermal expansion, an increase in the size of body is due to heating, is known as thermal expansion. Now the change in state of the body. Matter exists in three different states, which is solid, liquid, and gas. And the process of change from one state to another at a constant temperature is called a change of state. So when a solid is heated, when it is heated, a solid, it changes into its liquid form. That is known as melting. And when a liquid is cooled, that turns into solid again, the ice. That is known as freezing. When a liquid is heated, it changes into the process. It changes into vapor, which you can also call gas. The process of it is known as condensation. For example, when the water is heated, cooled, the reverse happens when the water gets cooled. The water condenses into liquid, the same fixed temperature. This process is known as condensation, the cooling. Then sublimation, directly solid to gas, and deposition is gas to solid directly. The change of state from liquid to gas into all temperatures, at all the temperatures, that is known as evaporation. Okay, so evaporation is a very slow process, while boiling is a fast process. During the change of state at a fixed temperature, heat is either absorbed or released. But this heat does not change the temperature of the substance. It is known as latent heat. The melting of ice can be demonstrated by this. So now, thermal expansion. It has been experimentally observed that when a substance is heated, it expands, and when it is cooled, it contracts. So we will now consider the thermal expansion in solid, liquids, and gases separately. A solid has a different shape and size. When a solid is heated, it expands in all directions. Hence the length area and volume all increase on heating a solid. An increase in length of the solid is called linear expansion. An increase in area, that is superficial expansion. An increase in volume is known as cubical expansion. Now, some examples is that cement floor is not laid out due to one piece because it would crack due to expansion in summer and contraction in winter. On the other hand, this floor is laid in small pieces with gaps in between to allow for the expansion during summers. This will be in your home as well. And if no gap happens, it will cause the rails to bend sideways, and this may result in however, glass strips can also be placed in the gaps. So that is one example, which is the simplest. There are 6 examples, but you can read it from your textbook. Now, the thermal expansion of liquids. The thermal expansion of liquids, like solid liquids, are also expands on heating. Liquids expand much more in solids when heated, and liquids do not have a definite shape, but they have a definite volume. Therefore, liquids only have a cubical expansion. Water on heating from 0 degree to 4 degree, it contracts and then only it expands. Did you know this also, that different liquids expand by different amounts of the same rise in temperature? Mercury expands more uniformly and moreover on a wide range of temperature. So mercury is used as a thermometric liquid. So now the thermal expansion of gases. Gases also expand when they are heated. Gases expand much more than liquids or also in solids. Like liquids, gases do not have a definite shape, so they have only the cubical expansion. What is cubical expansion? As we have read in thermal expansion, the increase in length of the solid is called linear expansion. The increase of area is superficial expansion, and the increase in volume. The increase in volume is known as cubical expansion. So gases and liquids are cubical expansion. And thermal expansion of air as well. So we have finished the let me write it down real quick. The scales of temperature we have done. Next, which we have done is the relationship between these 3, and then we have also learned the effects of heat. Effects of heat, it can be done into 3 types: change in temperature, change in size, and also the change in state. Solid to liquid, melting, liquid to solid, freezing. Liquid heated, to gas. It is boiling. Then we also learned that about sublimation and deposition, also evaporation. And then we learned about thermal expansion, which is of solid, liquid, and gases. So that is it for today's video. Thank you very much. Next video we learn about three modes of transfer of heat, and about conductors and insulators. So thank you very much for watching. Make sure to subscribe to our channel, like the video, and share this video with your friends. So thank you very much. Goodbye.